Hi everyone, this is a video on logarithms, logarithmic functions. This is the last section on logarithms, and here we'll take the algebra that we've seen, the logarithmic equations, and also transformations of functions that we've seen before, and take all this knowledge into logarithmic functions. So let's start. Great. The terms that we'll see are logarithmic function, inverse, a reflection of the graph in the line y equals x, shape of the exponential function, horizontal and vertical asymptotes, properties of function, transformation of logarithmic functions, inverse function, domain and range, asymptotes and intercepts, sketching, showing all important features, and double the distance of each point on the graph from the x-axis and the value of x in terms of b. So most of the terms should be familiar. Now we'll see it in logarithmic functions. So what we can understand by now is that logarithmic function is the inverse of the exponential function. So logarithmic are inverse of exponential function. Algebraically, this has the effect that the logarithmic and exponential function undo one another. Okay, so this is the definition for inverse, is that they undo one another like plus and minus and multiplication and division. Geometrically, it means that the graph of the logarithmic function is the reflection of the graph of the exponential function in the line y equals x. So if these are the set of x's, this would be the line y equals x. That means every point is reflected like a mirror on the y equals x. These are functions, exponential functions. So this is the classic exponential function. This is when a is greater than 1. Okay, let's say 2 to the power of x. And when a is a fraction between 0 and 1, then it is reflected on the y-axis. We see a reflection. Okay, since we saw that the exponential function and the logarithmic function are inverse, so graphically, they are reflected on the y equals x. So if this is y equals a to the power of x, the exponential function, this point here is reflected on the y equals x over here. If this is 1, then this would be, this is 1, 0, and then this is 0, 1. So every point here, x1, y1, it will be y1, x1. The values will just switch between the x and the y's. So this is the logarithmic function as it looks in the red when a is greater than 1. And when a is a fraction, this is the exponential function, and that would be the logarithmic function when it is reflected on the y equals x. So we understand that an inverse function always reflected over the y equals x. In this case, because they are inverse, the exponential and the logarithmic, then this is how it looks. Now, like this is reflected on the y-axis when this is greater than 1 and this is between 0 and 1, it's reflected on that. We can see that the reflection of the logarithmic function is also on the x-axis this time. You see that? So that would be when a is between 0 and 1. So find a way that it's easier for you to imagine. Now let's see the vertical asymptote. Okay, so in once we graph it, it's much more easier, but let's see what it means. Let's start with this, where a is greater than 1. Then we can see as x is going to the infinite, positive infinite, then also y slowly also grows until the infinite number. And when x is becoming really close to the positive side of 0, over here, then y approaches negative infinity. And in this case, when x approaches positive infinity, the y grows down to negative infinity. And here, when x approaches positive infinity, the y negative infinity, and when 0 approaches the positive side of 0, then y approaches infinity. So again, this is for inverse functions, okay? And we can see that the domain of one function would be the range of the other. And if this is the range of one, then that would be the domain of the other. And same for the asymptote. If the asymptote is y equals 0, then the vertical would be x equals 0. Here we can see the transformation of the logarithmic function. So this would be the function as it is. P ln x minus h plus k, where p, h, and k are constants. And here we can see how this ln x has changed into this one. Okay, I try to make everything as close to 0, so we get ln x. And here we see the positive, the plus 4 would be a translation upwards, horizontally. And the plus 3.31, that would be the counterintuitive. So it would be 3.31 steps to the left, because it's positive. And 2 times 2.26 would be doubling each value that we get here. Now, let's see an example. So consider the function log base 2 of x minus 1 plus 1, state the transformation, which maps log 2 of x to f of x. So we see we have a 1 in the x and 1 in the y, because the x is always counterintuitive, so it's always the opposite. Find the domain and range of f. So it's much easier for me first to draw the function, okay? So log base 2 of x would look something like that. Now it's plus 1, so it will move 1 by 1. And then it's minus 1, so that is a 1 move to the right. So it will move over here. And now this would be the asymptote, okay? This is the line that the vertical asymptote that the graph will never touch. Will look more like this. So now find the domain and range of f. So it's easier for me once I graph it. Finding the domain, we know that the log always has to be positive. So x minus 1 is greater than 0, x is greater than 1. The range, okay, I know y can be any value. And this is how we write the domain and range. That would be with these brackets. And so that would be the domain and range for any asymptote and x's intercept. Okay, so the asymptote here we can see is x, the vertical asymptote. X equals 1. And the x-intercept, we see it doesn't touch at all the y-axis. So there is no x-intercept, y-intercept. There's only x-intercept. For finding x-intercept, all we need to do is substitute y equals 0. So we get log base 2 of x minus 1 plus 1 equals 0, and we need to solve that. Base 2 equals minus 1. X minus 1 equals 2 to the power of minus 1. X minus 1 equals half. X equals 3/2. So we have a y-intercept. That's our x-intercept. So that is our algebraically, if we're looking for the y-intercept, we substitute x for 0. And in this case, we get log base 2 of 0 minus 1 plus 1. And since this is negative number, it's undefined. Sketch the graph. So that's the sketch of the graph. Now show all important features. So that would be x equals 1. That would be the vertical asymptote. And this x-intercept is 3.5. Find the inverse function. So it's good also to go over that again. The inverse function. So first we write the function. That would be our f of x. Y equals log in base 2 of x minus 1 plus 1. So now what we want to do, first of all, just understanding, you see this to the power of minus 1. Just a reminder, this means inverse. So the inverse function would be just switching between the x and the y. And now we need to isolate the y. How do we do that? Log base 2 of y minus 1 equals x minus 1. Y minus 1 equals 2 to the power of x minus 1. Then y equals 2 to the power of x minus 1 plus 1. Let's stop this video and then we'll solve some examples.